Good morning. We have come to second part of our experiments, that is volumetric estimation. So I completed the instrumentation. So in your volumetric estimation, the first experiment is determination of total hardness of given sample of water. So what is hardness? So hardness, the first thing which comes in our mind is the water sample which does not give lather easily with soap. That is not the answer, right? So why this hard water does not give lather easily with soap? This is because of presence of insoluble salts of calcium and magnesium. So hard water contains salts such as calcium and magnesium salts. What are these calcium and magnesium salts? So it might be carbonate, bicarbonate, chloride, sulfate, salts of calcium and magnesium. So I have two types of hardness. One is temporary hardness, other one is permanent hardness. So temporary hardness is caused due to bicarbonate and carbonate salts of calcium and magnesium. Whereas permanent hardness is caused due to chloride and sulfate salts of calcium and magnesium. So this temporary hardness can be removed by boiling the water. I'll just give you a simple example. If you take if you boil the water, and now you have solar water heaters, except we have geysers, etc. So earlier we used to have, they used to boil the water in the container in order to take bath, right? So if you use the same container continuously to boil the water, what will happen? At the bottom of the container and the walls of the container, you can see deposition of the salts. So that is because of temporary hardness. Bicarbonate will get converted to carbonate. You get deposition of calcium and magnesium carbonate, right? That is due to the deposition of the carbonate salts of calcium and magnesium in the walls of the container and bottom of the container. So this temporary hardness can be removed by boiling. What about permanent hardness? The permanent hardness can be removed by deionization, by chemical treatment. What is the chemical treatment? Deionization. We very well studied in our water technology, isn't it? So now what is this total hardness? Total hardness is nothing but sum of temporary hardness and permanent hardness. So sum of temporary hardness and permanent hardness, that is temporary hardness and permanent hardness put together, is called as total hardness. So how to determine this total hardness? We will take a sample of water, add buffer to maintain pH, and add an indicator, Echrome black indicator, and titrate it against the disodium EDTA taken in the burette until you get some change in color. So by knowing the volume of Na to EDTA consumed, we can estimate the total hardness present. So how does EDTA helps to find out? We'll see what are the chemical reactions occur. So whichever reaction where this EDTA used, disodium EDTA is used, it is called as what? Complexometric estimation. So any estimations we are using ethylene diamine tetraacetic acid or EDTA, it is called as complexometric estimation. So EDTA or ethylene diamine tetraacetic acid is sparingly soluble in water. Therefore, we are going to use disodium salt of EDTA. We are going to use what? Disodium salt of EDTA. That is Na2EDTA. So this Na2EDTA, the structure is as shown here. We have ethylene here, we have diamine here, and 4 tetraacetic acid groups. In 4 tetraacetic acid groups, 2 acetic acid groups are waste for us. Only 2 acetic acid groups are useful because the only 2 hydrogen acid groups are present. 2 hydrogen acids are free to react. So the water contains calcium and magnesium. We're least bothered about the carbonate, bicarbonate, chloride, and your sulfates. So when you add Na2EDTA from the burette to the conical flask, what happens? The calcium and magnesium present in the conical flask will come and sit in the CH2COO. The hydrogen will be liberated freely into the conical flask where the calcium or magnesium will come and sit over here. So when hydrogen is liberated freely into the conical flask, what will happen? pH will change. So in order to maintain the pH constant, we are going to add ammonium chloride buffer. So what are we are going to add? We are going to see later. But I'm telling you here itself. In order to maintain, you can see that H here, right? So if calcium should come and sit here, what will happen? H will go. Calcium will kick the H and sit here. Magnesium will kick the H and sit here. If the calcium kicks the H, where will the H go? H will go into the conical flask. As H goes into conical flask, what will happen to the pH? pH will decrease. If the pH decreases, what will happen? We will not get the right end point, isn't it? So if you want to maintain constant pH, you're going to add buffer. Okay. So you're going to add erythrochrome black tea indicator. So when you add the exact color of erythrochrome black tea indicator is blue color. Okay. So but when you add erythrochrome black tea indicator, it forms a complex with calcium and magnesium ions present in the conical flask. It becomes calcium EBT, magnesium EBT. So when you add Na to EDTA, the calcium and magnesium will go and react with Na to EDTA and becomes calcium Na to EDT or magnesium Na to EDT. Until calcium and magnesium is present with EBT, erythrochrome black tea, you will get wine red color. Once entire calcium and magnesium is bound with Na to EDTA, what will happen? You will have free EBT. What is the free EBT color? Blue color. Therefore, the end point will be blue. Okay. So, the calcium EBT or magnesium EBT is wine red. So, when you add Na to EDTA, the calcium will react with EDTA. It will get binded with that. Magnesium also will binded with that, liberating free EBT. When you get free EBT, the free EBT color is what? Blue color. Therefore, you get blue color. Okay. So, let us see how to proceed with the experiment. This experiment have two parts. First part of the experiment is preparation of standard Na2EDTA. We are going to take known weight of the Na2EDTA crystals. It will be transferred into 250 ml standard flask. Add one test tube of ammonia. So ammonia is added in order to, why ammonia is added? Why ammonia is added in order to increase the dissolution of EDTA. When you take 1 gram of Na2EDTA, in absence of ammonia also it will decrease. It may take 1 minute. But in presence of ammonia, it may just take 10 seconds. Therefore, we are going to add ammonia. It will increase the rate of dissolution. Dissolve the crystal with little amount of water and make it up to the mark. So, we are going to calculate the molarity of Na2EDTA. So later, we're going to fill the burette with the prepared standard Na2EDTA. What is standard Na2EDTA? Standard means the weight of the solute, volume of the solvent in which it is dissolved. Both are known. By that, you can calculate the exact strength, either normality or molarity or molality. That is called as standard solution. We're going to pipette out 25 ml of hard water into the conical flask. Add 2 ml of buffer. You know why you're going to add buffer, isn't it? To maintain the pH. Again, we're going to add indicator, a pinch of indicator. We're going to titrate until the color changes from wine red to clear blue color. So from the volume of Na2EDTA run down or consumed, you can calculate the total hardness of the given water sample. So usually it is determined using by ppm. The unit is ppm of calcium carbonate because it is simple to calculate. Okay, so for demonstration, tabulation and calculation of the total hardness, estimation of total hardness of given water sample, please click this below link. So here the preparation of standard solution and titration and the values are also tabulated to get the concurrent values, and the entire calculation till the ppm of calcium carbonate is done. So please click the below link for demonstration of this experiment. Thank you. Let's meet in our next experiment. Thank you.